Hello everyone and welcome to the World Cement podcast with me, David Bizley, Senior Editor of World Cement. It is now 2026 and the war in Ukraine rages on. On the 24th of February 2022, Russian troops crossed the border to finish the job they had begun in 2014 with the illegal annexation of Crimea. Heroic Ukrainian resistance has since turned what the Kremlin predicted would be a mere 3-day special military operation into 4 years of total war. However, amidst the ongoing destruction, there is some hope as groups from around the world work on novel ways to help Ukraine both endure this conflict and rebuild when it finally ends. One such source of optimism is the S3ROU project, a consortium of private companies and academic institutions working to solve the challenge of what to do with the concrete rubble produced by Russia's wanton destruction of Ukrainian towns and cities. Joining me today to explore this challenge and the progress towards solving it is Professor Leon Black from the School of Civil Engineering at the University of Leeds, a member of the S3ROU consortium. I just wanted to take a moment to remind you to register for World Cement. It's free of charge and gives you access to the latest issues of World Cement, both in print and online. Every issue comes packed full of regional analysis, technical articles, project case studies, and the latest industry news. Simply head over to worldcement.com, click the magazine tab, and register today. It's as simple as that. Happy reading. So, Professor Black, thank you for joining me on the World Cement podcast.
It's a pleasure. Thank you for inviting me.
So, for listeners who haven't previously heard of the Safe, Sustainable and Swift Reconstruction of Ukraine, or S3ROU project, give us an overview. What is it and what are your objectives for the project?
So thank you. Yes, the project's been funded by Innovate Ukraine, and it's a collaboration between academics and industry in Ukraine, academics in the UK, and a Dutch company based in the Netherlands. The aim, really, of the project is to maximize or facilitate and then maximize the reuse of the rubble that's been arising from the destruction of Ukraine caused by Russia's illegal invasion in 2022. We're trying to, as the name suggests, how can we maximize its reuse and maximize the value that we get from that? So not just landfill or using it for low value applications as can be used in the UK, but to really try and reuse the material to make fresh concrete and use it for reconstruction and rebuilding.
Okay, so to dive into that a little bit more then, what was the rationale behind taking this approach to concrete waste, the more standard routes? Why prioritize upcycling instead of simply putting it in landfill, which might have been easier, for example?
Somewhat glibly, there is simply too much in Ukraine. The sheer scale of destruction, we cannot just landfill it. So in the UK, we use, recycle or repurpose, I think is the figure, or is the phrase, almost 94% of construction and demolition waste, which sounds fantastic. However, the vast majority of that is for backfill, improving drainage on site and other low-value applications. That's a huge waste of resources. It's a waste of carbon. If you look at the carbon footprint of concrete relative to that of aggregate, if you're using concrete to replace aggregate for backfill, there's just this huge waste. Whereas in Ukraine, to be honest, the sheer scale of the material that's being produced means that many of the barriers to reuse can be overcome somewhat. And so it gives us this opportunity to actually maximize the reuse potential, if you like, of the end-of-life concrete.
Okay, excellent. So with the rationale behind the project clear, let's talk a bit about the processes and technologies involved. Step one is presumably to find rubble that's actually suitable for upcycling. So what exactly are you looking for and how are you distinguishing between waste concrete that you can work with and other less valuable materials?
Okay, yes. So some of the processing is being done by conventional means. You can strip out metal rebar readily with a magnet and other metals can be stripped out relatively easily. Then looking at primarily concrete waste. The big issue in Ukraine specifically is the use of asbestos. So Ukraine was one of the last countries to ban asbestos within construction. Now, most of this is used for insulation purposes. Given the winter climate, it was useful. And in a conventional deconstruction, that can be removed carefully and safely. When it's wanton destruction, you end up with a situation where the material can be mixed. And we have been looking at, can we develop sort of image processing techniques spectroscopic techniques where we can point a spectrometer at some rubble and say, is there asbestos in there? This is work that's ongoing. And so actually more realistically, it's coming down to knowing the types of structures by working with Ukrainian industry. One of the companies that's involved in Ukraine, Eco Plus Logic, has many years' experience in the construction industry. And they know the types of structures where the minimal or no chance of contamination from asbestos. And so from there, it is a case of identifying the concrete rubble, a little bit of pre-processing to break down the size somewhat. And then this is where Everox, the Dutch company, come in. And they have a process whereby they gradually break up the concrete and start to separate it into its constituent fractions. So the coarse aggregate, the recycled fine aggregates and the sands, and then a dust that's left at the end. Now, there is some commercial confidentiality around just what they're doing, but it's a combination of tumbling and abrasion coupled with gentle heat to separate the three sections. And they've put a lot of work into optimizing this, minimizing the energy input for maximizing the amount of, really it's the adhered mortar that's stuck on the outside of the aggregates. That's what you're trying to remove in any processing step. And so they've optimized this. By removing that dust, you're then left with, removing this adhered mortar, you're left with a dust, which they're looking to process further to produce other materials.
Okay. Now, it says that on the website that you've provided that you're also working on making the separation process fully mobile and truck mounted. What particular advantages does that offer? Why not simply transport rubble to a central facility rather than go to the rubble?
The big issue really is transport. Even though I mentioned earlier that you have this fantastic opportunity to reduce the carbon or the cost, the loss in carbon, if you like, from recycling concrete, or the loss in value, you're producing aggregates, and aggregates are not high-value materials. And so the costs associated with transporting aggregates can soon render the recycling process uneconomic. And this certainly is a major barrier in the UK, where the quantities of aggregates and the quantities of end-of-life concrete are much smaller on a particular site. But in Ukraine, you've got this large volume. I guess in some ways you could say it would make more sense to have a central processing facility. But there is another barrier in Ukraine, and that's energy is needed elsewhere. Having a mobile plant enables you to reduce the fuel costs, the fuel consumption, the carbon emissions that are associated with it. And that's the primary driver for having a mobile plant.
Okay. And so going to what you're actually extracting from the concrete, the aggregates that you extract can presumably just be used again in pretty much the same way. But what about the higher value items like the hardened cement paste? First of all, is this good to go? Does it need further processing? And what exactly are the available upcycling pathways, as it were?
Okay, so the material that comes out of the process, it has some latent reactivity, but it isn't as reactive as Portland cement. It can be used as a type 1 addition, so as a fine filler. Gentle heating does make a material that's, say, mildly reactive, but you can't replace more than a fraction of the cement. So some of the other techniques that people are looking at is forced carbonation, so blitzing the cement powder with carbon dioxide. That results in a material that is a mixture then of calcium carbonate and a reactive pozzolan. You can blend those with cement and you reduce the cement content, reduce the clinker content, and still get adequate performance. What we've also been doing in the project, this is Professor Theodore Hanine in Leeds, has been looking about, can you take this material and use it as a feedstock to remanufacture fresh cement? If you think about it, its chemical composition is already that of cement, albeit with a little bit of sand in there. So it makes an ideal feedstock, and looking at how you can process this to produce a low carbon cement is one of the aims of the project.
Okay. Now, some of the issues facing more broadly the adoption of greener cements and concrete products is that of inflexible building regulations, and in some cases, even reluctance from end users to try new products. How are you dealing with the hurdles of this kind, and have you encountered this challenge as well?
Yes, absolutely. Now, we need standards. Standards are there for a purpose. They provide a degree of confidence to the construction industry. At the same time, all of us involved in this project are looking at how we recycle concrete. On this project, it's in Ukraine, but we're also doing research about how we do this in the UK. And the drivers are subtly different, but ultimately, we can use recycled aggregates and recycled materials within standards. Many people just believe that, it can't be used, but there are applications where they can be used. One of the biggest issues really is overcoming the inherent conservatism within the construction industry and this reluctance from end users. And so what we're trying to do here, it gives us this fantastic opportunity to produce these materials and produce demonstrator projects. So Eco Plus Logic are looking at precast concrete products and pressed, so concrete flags for the reconstruction of a square, where they can produce these products from entirely recycled materials. And then because they're pressed products, also actually impress in them a little bit of the history of the project and why this is important. And so it's about providing these public demonstrations of the technology to show that it's achieving something.
Okay, so this is effectively how also you're validating the performance of the end product and letting people know that these products will work.
Yes.
So looking ahead then, this technology could presumably be used elsewhere beyond Ukraine. Do you currently have any plans to deploy it elsewhere in the future?
Yes, as I said, everybody on the project is looking at the recycling of concrete. We've been partnering with Everox in Netherlands. There are other companies, both in the Netherlands and in the UK, who are doing these sort of projects and this sort of work. The drivers and the barriers are slightly different. As I've mentioned, the sheer quantities of concrete and demolition waste that are being produced in Ukraine almost provide an opportunity to overcome the barriers around transport distance and availability of large quantities of material. But the technology could be employed anywhere where post-conflict reconstruction, post-disaster reconstruction, and yes, I'm sure I speak on behalf of Everox here, they are looking for commercial exploitation opportunities around the world.
Okay, excellent. So to wrap things up then, looking ahead over the next few years, what highlights can we expect to see from this project over the coming years?
I'm an academic. From an academic perspective, we're going to have scientific papers published to demonstrate the feasibility of this work. And these papers are starting to come out now. But it's more than that. It's the demonstrator projects that I've mentioned. It's about wanting to see that the work that we have done has actually made a difference. That sounds very cliched, but I think it's incredibly important in this instance. What I also hope is that actually it will foster further collaboration between Ukraine and the UK. Again, one of the reasons behind the funding from Innovate Ukraine was to foster collaboration and to provide opportunities for UK businesses to be involved in Ukraine and to be involved in the reconstruction. So we're hoping that there will be demonstrators, that there will be outcomes, and that we will actually contribute to the reconstruction of Ukraine.
Okay, excellent. Professor, that's about all we have time for this episode. Thank you so much for taking the time to guide us through this project. And thank you very much for joining us on the World Cement podcast.
Thank you very much. Thank you for having me. It's been a pleasure.
And as always, thank you to everyone in the World Cement podcast audience as well. If you enjoyed this episode, please make sure to like, review, and subscribe if you haven't already done so. And go and check out some of our previous episodes too. We're building up quite a back catalogue now. That's all from me. Goodbye for now. I just wanted to take a moment to remind you to register for World Cement. It's free of charge and gives you access to the latest issues of World Cement, both in print and online. Every issue comes packed full of regional analysis, technical articles, project case studies, and the latest industry news. Simply head over to worldcement.com, click the magazine tab, and register today. It's as simple as that. Happy reading.